Hi, this is the next video of first section displaying a measure on a 2D graph like an oscilloscope. In the previous video, we saw how to synchronize multiple threads using T-event. In this video, we'll use the T-threaded queue extended class to bring out data from the background thread to the main thread. An oscilloscope is a type of electronic test instrument that allows the observation of constantly varying signal voltages. Usually information is shown as a two-dimensional plot graph of one or more signals as a function of time. In this video, you'll implement a type of oscilloscope to display data generated by a background thread. Obviously in this video, you'll not create an accurate oscilloscope, rather a nice real-world utilization of retrieving data and using it continuously in the GUI. You'll use the T-threaded queue extended class to bring out data from the background thread to the main thread. The approach is similar to that shown in the video talking with the main thread using a thread-safe queue, but in this case, we have to show data in a complex way on a 2D graph showing only the last end data retrieved. Open your project Thread Measurer and then run it. So this application has a background thread acting like an analogical signal generator that is able to generate a sine-style stream of data and a graph that plots these data. The resulting application will look like this. You can adjust the resolution of the plot number of points used to draw the sine using the track bar on the left-hand side. Let's see the most important parts. The thread used as a signal generator is very simple. As you can see in this code, it uses the system.math.syn function to generate a sine wave form. Every 10 milliseconds CA, a new value is appended to the queue. This value is the sample you get from the measured system. The code is highlighted here. Being a classic producer-consumer, this architecture has to deal with the classic problem of a queue being full and not accepting any data until someone starts to dequeue from it. At regular intervals, a T-timer dequeues all the values from the queue and appends them to a different queue living in the main thread. This queue must have a field size, so if there are more values than what is defined by the resolution, the oldest values are dequeued until the queue size is equal to the maximum length permitted. This adjustment is done in the timer event handler with this highlighted code. The actual values are plotted on a simple 2D graph using T-paintbox as canvas. Remember that only the main thread should repaint and call paint procedures. This highlighted code is for the onPaint event used to draw the plot. FireMonkey Canvas does not allow you to draw an open polygon. An open polygon is a shape composed of two or more line segments where the first and the last points are not connected directly. Here, we need an open polygon. So, how to do it? Here's the code of the Draw Open Polygon method. Showing dynamically changing data is always a challenge and is a typical synchronization problem if you have to read from a blocking and very fast data source. However, using queues in an efficient way can help to reach the correct architecture. If you have very high concurrency, many consumers or many producers, or a very high producer speed compared to the consumer speed, you may have some performance improvements using lock-free data structures. Unluckily in Delphi, there are no ready-to-use lock-free data structures. However, there are very good libraries, even open source, that implement it in the context of multi-threaded programming. One of the most popular libraries, although it is only for the Windows platform, is the open-source OmniThread library from my friend Primoz Gabrigiliak, which you can get on this link. Amazing! So now we know how to display measure on a 2D graph like an oscilloscope. In our next video, we will use tasks to make your customer happier.